Okay, this is 42 from the homework from 6-1. So it said a bridge is to be built across a small lake from a gazebo to a dock. Bearing from the gazebo to the dock is south 41 degrees west, which is marked on your little diagram. That's what's here. And then from a tree 100 meters from the gazebo, that's where your measurement from 100 comes from. The bearings to the gazebo and to the dock are south 74 degrees east and south 28 degrees east, respectively. So it's saying in that order, right? So it says from the gazebo, or sorry, from the tree to the gazebo is south 74 degrees east, which is where that one comes from. And then to the dock would be south 28 degrees east, which is where that measurement comes from. Find the distance from the gazebo to the dock. So I'm looking for this measurement here. Okay, so there's a lot going on in this picture. So if you look at it, remember you're dealing with north-south lines, right? Which we talked about yesterday was what? What kind of line is that north-south line? It's vertical, right? So it kind of drew it in there for you, but if you could picture it that way, what's true about all vertical lines? They're parallel. And so this, while it's not an easy question, I could have like easily just said don't worry about it, but it kind of forces some review from geometry because that's called a transversal, right? And the angles formed by a transversal have a bunch of different relationships. So you've got alternate interior, alternate exterior corresponding, which are all congruent to each other. Okay, so like if you had a measurement here and a measurement here, I would have said that those were corresponding, so those are congruent. Or alternate interior, which would put it here and here, those would be congruent. Or alternate exterior, which would be like something here and something here, those would be congruent. None of those are the case here, but I do have an angle here and an angle here that I could use because I need that little sliver of an angle inside. Those are called same side interior or consecutive interior. And if the lines are parallel, then they are what? Supplementary, which means that those two red angles add up to 180. So if I did 180 minus the 74, I get 106. That's this whole angle, but then I have to subtract from it the 41, and I get the 55 degrees. That's that sliver of an angle inside. Now I got to use the triangle that's drawn. What's true about all the angles in a triangle? 180 degrees. So this inside would be the 74 minus the 28, or 46 degrees. And then 46 plus 55 is 101. Subtract that, I get 79, which is there.
I think it actually is 65.
Did I do the math wrong?
Yeah.
It's very possible. Yes, sure did. This is 65. Which leads to this. Oh, that's still 46. There, now we're right? So now I'm dealing with a triangle on the inside. I've got one complete ratio for this angle, right? So I can say that 100 meters over the sine of 69 would equal, I'm looking for this one, which pairs with the 46. So x over the sine of 46. And then you cross multiply and divide. And that's where your answer comes from. So I think I told you yesterday, I would say that your, like the quiz questions, they don't have diagrams, so they're a little bit less complicated than this to draw. Okay, but obviously these are all skills that are super important. I've never seen a standardized test without some mention of those special angles. So you want to make sure it's good review to know all that stuff. Parallel lines, special angles, super important. So law of cosines. Law of cosines is another method to finding the lengths of angles and sides of triangles that are not right triangles. So depending on the type of information that you're given will drive you to decide whether you're using law of cosines or law of sines. It's not like you can use one or the other. You're going to be able to only use one of them depending on the type of information you're given. The good news about law of cosines is there's not like an ambiguous case where you have to like try for a second triangle. The bad news is that the formulas are a little bit more complicated, okay? There are three formulas for each part, but if you just learn one, you can derive the others, okay? So I gave you one so that it kind of forces you to write the other two out. The formula for finding a side is that a squared equals b squared plus c squared minus 2bc times the cosine of a. So in this case, and you'll see in a moment, this would be a side angle side scenario. You're given two sides and the included angle, which we can't use law of sines for. You're only going to be able to use law of cosines. So if I'm looking for side A, then I would square each of the other sides individually, add them together, subtract from it 2 times the product of those two sides times the cosine of the same letter of the side I'm looking for. So that's your included angle. So if I was looking for b squared would equal a squared plus c squared minus 2ac times the cosine of b. If I was looking for c squared would equal a squared plus b squared minus 2ab cosine c. So if you think about the fact that all of these are squared, if I wanted to find just a, what's going to be my last step? Take the square root of whatever's on the other side of the equal sign. The good news is your calculator can do all of that for you one step, okay? You just got to be really careful. The alternate form is used to find the angles. So if I actually took this and solved for the cosine of a, I'd get b squared, or a squared, sorry, equals b squared plus c squared minus 2bc cosine a. I could subtract the b squared, the c squared, and then divide by negative 2bc. The negative changes the signs of everything, which is why it becomes b squared plus c squared minus a squared over 2bc equals cosine a. So if you can't remember the bottom ones, okay, you can derive them. It's not going to be fun to have to do it every time, but if you wanted to do it once at the beginning and write it out, that's fine. Or you can just memorize one of each and learn the pattern. And then because these all say cosine of the angle equals something, what's going to be my last step to get just the angle? How would I get rid of the cosine at the front? Go on, cosine negative 1. So you're going to do the inverse of what you get, okay? When we get to these, and I'll talk about it when we get to them, but you have to be really careful how you type those in your calculator because order of operations will mess that up. Anybody still copying them down? Okay. So the angles would be the sum of the two letters that do not match the angle that you're trying to find. So if I'm finding A, then I do b squared plus c squared minus the letter that does, so minus a squared, over 2 times the two letters that do not match the angle you're trying to find. So what do you notice about everything that you need for the bottom? What type of things are you plugging in there? So if I'm trying to find angle A, I need to know what 3 pieces of information? All 3 sides, right? So law of cosines, to find the angle, you need all 3 sides. So that's a side, side, side scenario. Anybody still coming down now? Okay. So the first case, side angle side. This is where you're looking for the third side of the angle. The third side of the triangle first. And then once you have all 3 sides, you can actually pick between switching to law of sines or keeping with law of cosines. You have that choice once you get the first one. But to get the first one, you're going to have to do law of cosines. You can't do law of sines if you have side angle side. So it will look something like this. And again, quiz-wise, no diagram. So if you want to draw the diagram, go for it. If you want to get in the habit of not needing it, that might be a good idea too. Okay. If I draw it, so this is A, this is B, this is C. So I'm saying angle A is 39 degrees, side B is 21 degrees, and side C is 42. So hopefully you can see you've got side angle side. I can't use law of sines, which means I'm going to use law of cosines. And the first thing you have to do is find the missing side. So I'm missing A. So I would do A squared equals B squared plus C squared minus 2BC cosine A. B squared is 21. C squared is 42. 2 times 21 times 42 times the cosine of the angle opposite the side I'm looking for, which is 39. And you can actually type that whole thing in your calculator all at once, square root of, because I'm going to eventually have to take the square root. And your calculator's natural order of operations, well, it follows the natural order of operations, will solve it the way it needs to be done. So square root 21 squared plus 42 squared minus 2 times 21 times 42 times the cosine of 39. And I get A equals 28.88. All right, so now I've got side A, and you have two choices, right? One is what? I can switch to law of sines. I now have one completed ratio, right? What's the other? Law of cosines. So I'm going to do law of cosines just so you see it because we haven't done it yet. Because law of cosines for an angle. We did law of cosines for the side, but we didn't do law of cosines for the angle. Let's say I'm going to solve for angle B. So I would say the cosine of B equals A squared plus C squared minus B squared over 2AC. So A squared is 28.88 squared plus C squared 42 squared minus B squared 21 squared over 2 times A times C. So now when I type that in the calculator, and this is where you want to be really careful. I can do it all in one space, but if I did cosine -1 of that whole thing, what's going to happen if I just type this in? What does order of operations do first? There's no parentheses, so that what comes after the P? Exponent, so it's going to square them, right? Then what would happen? What comes after the E? Multiplication or division, and we go left to right. You with me on this? Yeah? So if I type that all the way in the calculator, the first thing it's going to do is take 21 squared and divide it by 2, which messes up my entire process. So when you type this in the calculator, and you can do it all in one space, you could do cosine -1. You're going to open the parentheses, because one parentheses is already going to be open, but you want to open the parentheses for your numerator. You're going to do 28.88 squared plus 42 squared minus 21 squared. You're going to close those parentheses. You're going to do divided by, you're going to open another set of parentheses. 2 times 28.88 times 42. You're going to close those parentheses. And then you could probably hit enter, but if not, it's going to force you to enter another set of parentheses. So you can do that all in one step. You just have to be really careful. It'll probably give you an error, because it's going to try to do the cosine -1 of something bigger than 1. So this, it tells me angle B is 27.23 degrees. We said the other way to do it would have been law of sine, so you can choose between them. Once you get the first one, I could have done A, which is 28.88, over the sine of A, which is 39 degrees, equals B, which is 21, over the sine of B, I would have cross multiplied 21 times the sine of 39 divided by 21, and then second sign that answer, and I get 30, wait, hang on, 28. .23 degrees, so they should match. So if you've got extra time, it's a good way to check your work, okay? But you could choose between those two methods. And then the only piece of information that I'm missing is angle C. What's the easiest way to find it? Subtract it from 180. So 180 minus the 39 degrees minus the 27.23. And I get angle C equals 113.77. Questions so far? You want to make a habit of at least giving me the line in which you would type in. So if I'm doing law of cosines, you want to give you at least that, because if you type something wrong in the calculator, it's wrong, you have no idea. You're living in this blissful little piece where you're like, oh, I got 100 on that quiz. You type the wrong answer in the first thing, which led to the wrong answer from there on out. And no partial credit, which would stink. So you want to show me some work so that I know that your calculator is where you messed up, and I can at least give you some partial credit. There's 8 questions on your quiz. 2 from law of sines, 2 from law of cosines, an area of each, which we're going to get to in a moment, and 2 word problems. All right, the second type. All right, so side is the other type of law of cosines. So law of cosines is side, angle, side, and side. If you get given those 2 pieces of information, which on the actual problems, it's going to be grouped together, but when you get to word problems, you're going to get given different types of information, and the word problems are mixed together. So you have to look at what you're given, what you're looking for. If you have all 3 sides, you know you have to do law of cosines. If you have 2 sides in the included angle, you also have to do law of cosines. Everything else is going to be law of sines. Okay? So side is use the law of cosines to find the angle opposite the longest side. Okay? What happens here with law of cosines, and I explained this the first class, and I think I super confused them, so I'm going to try not to do it again. But when you find your first angle, so let's say I get a triangle. Let's say I call this A, B, C. With law of sines, side, you are given all 3 side lengths. So let's say, I don't even know, let's just say that this is 5, 6, 8, something like that, okay? And the first thing I do is find one of the missing angles. So let's say I find angle A. Let's say I find this to be, let's just make stuff up, 30 degrees, okay? Now, that's the first step, law of cosines. But now I can switch to law of sines, right? Look what I have. I have a full complete ratio for the A's, right? So I can switch to law of sines. But the pattern and the information that I have to use law of sines is, if I'm trying to find, let's say, angle B, is 2 sides and this angle, which is what kind of angle? The non-included angle. So what can happen is you actually introduce an ambiguous case in which it doesn't exist to begin with, okay? So we eliminate that possibility with law of cosines by starting with the largest side. If you start with the largest side, or the angle across from the largest side, you eliminate that second triangle. It technically does not even exist. You bring it in when you shouldn't, okay? So you will know, because you end up with an obtuse angle usually, okay, that the largest one should be opposite the largest, which would make it sense. And you eliminate the possibility of the ambiguous triangle. So you have 2 choices with law of cosines. Do it all the way out with side, every single part law of cosines. Or do law of cosines and switch to law of sines. But if you do that, you need to start with the largest angle, okay? And we know the largest angle because it's opposite the largest side. So when you're given side, and you're solving your triangle, you always want to pick the largest side to start with, okay? And then you can switch law of sines or law of cosines. That's going to get you the second angle. From there, you subtract those two from 180 to get the last one. Okay. So example 2, again, all three sides. This is my side scenario. A is 11, B is 14, and C is 20. So if I'm going to switch between law of cosines and law of sines, then I have to make sure that I pay attention to the order in which I solve the first one. What angle would you be solving for first? C, because C is the biggest side. Yes, everybody understand that? Yep. So I'm going to do the cosine. Oops, the daisy. I'm going to do the cosine of C equals A squared plus B squared minus C squared over 2AB. I'll be honest, a lot of times with cosines, I don't draw out a triangle. I think it's faster just to go off the information you're given. But it's up to you. If you like the visual, go ahead and do it. So I'm in my calculator going to type cosine -1. Open up my parentheses. A squared is 11 squared plus B squared is 14 squared minus C squared is 20 squared. Close my parentheses. Divided by, open my parentheses, 2 times 11 times 14. And I get the angle C is 105.63 degrees. Now I have two choices, stick to law of cosines or switch to law of sines. Because we started with the larger of the two, we don't have to worry about the ambiguous case. So I'm gonna do law of cosines just so we can get the practice of it, but you could switch to law of sines at this point. So if I want to do law of cosines, I would do cosine. Let's say I'm going to solve for A this time. So I get cosine -1. A would be B squared, which is 14 squared, plus C squared, 20 squared, minus A squared, 11 squared, divided by 2 times 14 times 20. And I get angle A is 31.98 degrees. And then for angle B, all I have to do is subtract those from 180. Did anybody use law of sines? Once you switch, did you get the exact same answer?
I got 31.99.
So think about why that happens. Because you use it rounded. So when you switch, which is fine. When you switch to law of sines, which is why you're going to give me your work. When you switch to law of sines from here, I would do C over the sine of 105.63 equals A, which is 11, over the sine of angle A, which is what we're finding, okay? And when you do that, you are using a rounded measurement to get a new measurement, okay? So your answers might end up being 100th off or a couple hundredths off. That's fine. Just show me what you're doing, and I'm fine with it. As long as you're within like a tenth, you're probably okay. Questions on side. So two types for law of cosine, side, angle, side, in which you got to find the third side first and then continue. And in this case, I'm side.
After when you first start, you choose the longest side. Do you have to like pay attention to sides after that?
Nope. So what you did is you basically said, think about all the ambiguous cases that we had, right? The first angle was always larger because we did 180. Usually it was like ended up being obtuse, right? You're basically saying the obtuse angle matches the largest side, which should make sense. So it eliminates that second case. Okay, so this is like a baby step in between a word problem and an actual word problem, right? It says find theta between the two paces for both the carnivore and the herbivore. So you've got two different triangles here. And in both triangle, you're trying to find theta. So go ahead and find it. Two different triangles, two different thetas. You could call this A, B, C if you want, and D, E, F. Okay, doesn't matter what you call them as long as you make sure you plug in the right parts. All right, so for the triangle on the left, you should have gotten theta. We called it A, but we should have gotten that theta was 156.85 degrees. And on the right, 99.59 degrees. Everybody good? Yes? Okay. All right, this one, so we're actually going to do this first part, but not the second part. You can cross through that second question, and I'm going to give you values to put in here. Go ahead and add those values on. Actually, that looks like it might be smaller than the other one.
Sorry, what did you say the answer to Law of Cosines?
All right, so this says, if you are on island B, what bearing should you navigate to go to island C? So we're back to bearings. Remember that bearings have two parts to it. They've got the degree and they also have a direction. So if I'm starting at island B and I want to go to island C, I would make B my origin. So if I drew my axis here, what direction would I have to go to get to island C? Northwest, right? North and then west. And then what I have to figure out is what's this angle measurement there, right? Because that's the bearing degree I would have to take. How could I find that? North. Good. So you're going to find the angle in here, which we're going to call B, and then subtract it from 90 because your north, south, east, west lines are perpendicular. So you only have to find the larger side first if you're continuing to find the rest of them using law of sines. Because we're honing in on just one, it's okay. Does that make sense? All right. So I got to find angle B. So the cosine of B would equal, so if this is A squared plus C squared minus B squared over 2AC. So I add the two that I'm not looking for, subtract the one I'm looking for, and then I divide it by 2 times the ones I am not looking for, so the first two. So I'm going to do cosine -1 of A squared, which is 22, plus C squared, which is 23, minus B squared, which is 16. 2 times 22 times 23. And I get angle B is 41.58 degrees. And again, we said that's what's inside the triangle. So to get the part outside, we said we have to do what? Subtract that from 90. So north 48.42 degrees west would be the bearing you're taking from B to C. Questions so far? Okay. The last part of law of cosines is another area formula. So you're finding the area of a triangle, but you're using different types of information. So if you remember from the law of sine section, we used side, angle, side, two sides and the included angle. So if I have those for 3 pieces of information, then I use that 1/2 AB times the sine of C, that formula. If I'm given 3 sides, then I use what's called Heron's area formula. So on your quiz, I wrote like use Heron's formula, but the other one doesn't really have a name. So it just is like find the area of the oblique triangle. Pay attention to what information you're given. Unless you're given all 3 sides, you can't use Heron's. If you're given all 3 sides, you have to use Heron's. Okay. And again, this is of a triangle that's not a right triangle. So the first thing, I know it's kind of out of order, but the first thing you're going to find is what S is. And S is the sum of the 3 sides divided by 2. So it takes side A, side B, side C, add them up, divided by 2. What's important on that is don't round it. So if I get something like 7.83625, I want to use 7.83625 every time. Otherwise, you're making it less accurate. And then I would do the square root of S, whatever you got for S, times S minus A, times S minus B, times S minus C. And that gives you the area of your triangle.
And it's only for SSS?
It's only for side, because you need all 3 side lengths for this. If you had 3 side lengths and an angle, you could choose either one, and they should both give you the same answer.
You could choose between this one and the other one?
Correct. You would just have to use the 2 sides and the included angle for the other one.
But on the quiz, there's going to be some.
On the quiz, you're given just 3 sides, or you're given the 2 sides and the included angle. So you're going to do one of each. Yep. All right, so it says find the area of the triangle with the given side lengths. So I'm going to first take A, B, and C, add them together, and divide by 2. So 5 plus 7 plus 10 divided by 2, which is 11. That's my S. And then I would do the square root of S times S minus A times S minus B times S minus C. And I can simplify that first and then continue, or you can let your calculator do the work for you all the way across, because when it gets to the decimals, it's not going to be so easy. So this would be 11 times 6 times 4 times 1. And I get 16.248, which is 25. This is area. So it's units squared.
Why'd you put the 11 equal to 5?
That's an S. It's just a sloppy S.
Oh, S.
Yeah. For B, I get S is 3.125. So I'm using that every single time. So area is the square root of 3.125 times 3.125 minus 3.05 times 3.125 minus 0.75 times 3.125 minus 2.45. And your calculator can do that all. Just make sure you watch your parentheses. So 3.125 times 3.125 minus 3.05. 3.125 minus 0.75. And 3.125 minus 2.45. And I get 0.61 units squared. So again, be careful with this. Make sure that you don't round your S. You don't want to make your area further off. And if you round it, you are making it further off 4 times because you've used a rounded measurement 4 times in that equation. Questions on anything related to law of cosines? So my advice for you today is make sure you keep rewriting law of cosines when you do your homework so that it sticks, okay? You don't want to take a picture of it and use it over and over again because you won't remember it. Law of sines is easy formulas, okay? But then you got to worry about your ambiguous case, and then you've got 2 area formulas, and then you've got the law of cosines.